number 17, simplify. All you have to do is factor each of these. This is a good test to see if you can factor or not. So we're going to factor all these like this. Every one of them is a trinomial. Trinomials factor into two binomials. First one, we just get x and x. It's a plus there, so we need a 5 and a 4. The bigger one's going to be plus. The little one's going to be minus. Most of you factored this fine. I'll show you where your problem came in. So you get x minus 2, x plus 1. This one's x. They're both positive, so these are both going to be positive. So it's going to be 8 and 2, add up to 10. And this one is negative, so we get x. X, one's negative, one's positive. So it's going to be plus 8 minus 5. That you did pretty well. The problem is you started crossing off things that weren't cross-offable. So let's look. We have an x plus 8 and an x plus 8. We have an x minus 5 and an x plus 5. They cannot cross off. We have an x plus 2 and an x minus 2. They can't cross off. So that's all that crosses off. So we just multiply across the top, x plus 5, x minus 4, x plus 2, over x minus 2, x plus 1, x minus 5. And that's it. It doesn't look nice, and so some of you thought you'd just take it on your own and just get rid of things that kind of matched. But they have to be exactly matching factors to cross them off. Okay, 18, add. These are two fractions. We cannot eliminate the fractions because it's not an equation. If it would have had something like equals 2 over here, we could have multiplied everything by the common denominator and eliminated the fraction. But it's an expression, not an equation. So we have to find a common denominator. It's like adding 2/3 and 1/4. You have to find a common denominator. In order to find common denominators, you have to make sure all the denominators are factors. So we get x plus 2, x plus 1, because they add up to 3. Our common denominator, we need an x squared, an x plus 2, and an x plus 1. Multiply the numerator by what's missing. So we're missing an x plus 1 right here. And this one is missing the x squared. And we just multiply that out, and that's our answer. 6x plus 6 minus 3x squared. Typically, you want to try to factor it, but factoring doesn't help. If you take out a 3, there's nothing else you can do. So this is your final answer. You should look to try to factor it to see if you could potentially cross out like factors, but you can't factor it, so you're done. All right. Our favorite kind of problems are distance problem. I copied this one straight out of the book. I changed the names from like Little Bear to Happy Bear or something like that. We have Little Bear and Happy Bear actually. So I changed them from something, but the numbers are exactly the same. We have, in this problem, at 10 a.m., Little Bear trotted off in one direction at 6 miles per hour. So the rate of Little Bear is 6 miles per hour. He left at 10 a.m. At noon, 12 o'clock, Happy Bear lopped off, or loped off, or whatever he did, in the opposite direction. If they were 68 miles apart at 4 p.m., how fast did Happy Bear lope? So this is one of the ones where this distance plus this distance has to equal 68. So it's the distance of Little Bear plus the distance of Happy Bear equals 68. We always take our distances and make it rate times time. So rate of Little Bear, time of Little Bear, equals rate of Happy Bear, time of Happy Bear, equals 68. Now let's try to figure out the things that we need. The time of Little Bear from 10 to 4 would be 6 hours. Then we don't know that the time of Happy Bear is 12 to 4, so it's 4 hours. We don't know the rate of Happy Bear. So that's the only variable we don't know, so we just plug in what we know. So it would be 6 times 6 would be rate times time. Rate we don't know. We know the time is 4, so it's 4 rate of Happy Bear equals 68. we just subtract 36 from both sides. So we have 4 rate of happy bear equals 32. Divide both sides by 4, and we're going to get the rate of happy bear equals 8 miles per hour. If you didn't put the miles per hour, you missed a point. So this one was an easy distance problem, and I gave you the exact one if you would have done your practice problems. All right, problem number 20. Let's just move things up and down and get rid of our parentheses all in one step as much as we can. So we get p squared, m to the 5th, p to the minus 3. I'm going to move this one down because this negative exponent, you can't raise a number to a negative exponent, so we have to move it to the bottom right away. So we get 8 p to the 3rd, m to the 6th, m to the negative 4, m, p to the 3rd. Now I'm going to combine everything on the top that you can combine and everything on the bottom that you can combine. When the bases are the same, you add your exponents. So we have m to the 5th, p to the negative 1. Hopefully I didn't forget anything. Then on the bottom, we get 8. Here's our p. We get 3 plus 3 is 6. And then m's is, we get 2 plus 1 is 3. Now we have to combine our m's together. We're going to bring this one up to the top because there's more on the top. We don't want a negative exponent. So we get m squared. And this is negative, so we need to bring it down to the bottom. So we get 8p to the 7th. And that's your final answer.